Hello and welcome to this video. I am Karnesh Jory and this video is about string library functions in C. The string library is important. There are many functions which are used in C programs. In this video, we look at strlen, strcat, strcpy, strcmp, strstr, strtok, memset and memcpy functions, and we look at some example programs. So let's get started with the string library functions in C. The first function is strlen and it computes the length of the string. The length of a string is number of characters not counting the null character. strlen returns the length of the string as size t, which is normally long unsigned int on most GNU Linux systems. For example, strlen of hello is 5. The strcat library function is for concatenating two strings. There are two input strings, source and destination. It concatenates the source string at the end of destination string. There are two variants, strcat and strncat. strcat concatenates the source string src at the end of destination string. First, the null character at the end of destination string is removed. Then the source string is copied at the end of destination string and the terminating null character is written. Coming to strncat, it has a third parameter, a number n. If the source string src has more than n characters, only the first n characters are concatenated to the destination string dst, and then the terminating null character is written. Now, very important, the destination string must have enough space for accommodating the characters from source string and the terminating null character. Both strcat and strncat return a pointer to the destination string dst. Here is an example of strcat. We are concatenating two strings hello and world and then hello world and the exclamation mark to get the final string hello world exclamation mark. And another example, this one is of strncat. Here the string greeting has only 12 bytes. Since it has already 5 characters as dear followed by a space, we can add a maximum of 6 characters, which makes it 11 and 1 byte for the null character. Now we might have multiple strings that we want to concatenate to greeting one at a time, so we use strncat with n equal to 6 so that there is no buffer overrun, and we print the first 6 characters of each company name after the string dear followed by a space. strcpy is for copying source string src to destination string dst. It is quite similar to strcat. The difference is that here the source string is copied to destination, whereas in case of strcat, source string is concatenated to destination. And as in case of strcat, there are two variants, strcpy and strncpy. And strncpy copies at most n characters from source to destination. The destination string must be a variable string. It cannot be a constant string, and it must have enough space to accommodate characters of source string. In case of strcpy, all characters of source, including the null byte, are copied to the destination. But in case of strncpy, if there is no null byte in n characters, the destination string is not null terminated. So there is one particular aspect where the behavior of strncpy is different from strncat. Let's look at this aspect with an example. So here we have an example. We have an array greeting of size 12 bytes. In this array, we will assemble a message like dear space followed by 6 characters of a company name. So first we clear the array with spaces. Next we write dear space using strcpy in greeting. So now 5 characters have been copied, and keeping 1 byte reserved for the terminating null character, we can write a maximum 6 byte string. We do a strcat for 6 bytes from the string company1. We print the greeting and we get the message dear space advent, and strlen of greeting is 11 bytes as it should be. Since we have a 12-byte buffer, 11 bytes of text and 1 for null, this is as expected. strcat copies 6 bytes, writes the null byte, and strlen of greeting is 11. Now we will try strncpy. We write dear space 5 characters, array index 0 to 4 are written. We write with strncpy at greeting array index 5 onwards 6 characters. 5 initially and 6 now, that is 11 plus 1 for the null character. What do we get? The string is having junk characters at the end, and the strlen is 25 characters, which is wrong. The problem is that we use strncpy for writing 6 characters, and these 6 characters did not contain the null character. What we need to do is to ensure that there is a null character in these 6 characters. Actually, since we are including the null character here and we have written 5 characters initially, we can write 7 characters now. So we set company to 6 as null and do a strncpy at greeting 5 from company 2 for 7 characters, and we get the correct string with strlen of greeting as 11 characters. The strcmp function compares strings S1 and S2, and the comparison is done as per the ASCII character code. strcmp returns 0 if string S1 is equal to S2, a negative value if S1 is less than S2, a positive value if S1 is greater than S2. strncmp works just like strcmp, except that only the first n characters of the two strings are used for comparison. The strstr function finds the first occurrence of substring needle in string haystack. While searching, the null character at the end of substring needle is not matched. strstr returns a pointer to the location in haystack where the substring needle has been found. If the substring is not found, null is returned. This is the default search, that is, it is case sensitive. If we want case insensitive search, we can use strcastr. However, it requires a feature test macro, that is _gnu underscore source needs to be defined before any of the include files in the program. In this example, the string company has a word widget starting with uppercase W. We can find it with strstr using the substring widget spelled exactly in the same way starting with uppercase W. Suppose we want to find the word widget with characters in either case, we can use strcastr. Now, a very important and useful string library function is strtok, which is for getting tokens from a string. You can designate one or more delimiters for a string. A delimiter is a character like period, comma, semicolon, hyphen, etc. Whatever text comes in between two consecutive delimiters is a token. So delimiters break up a string into parts or tokens. A token is a null terminated non-empty string. There are two parameters in the strtok call. The second parameter is a null terminated string comprising of delimiters. The first parameter is the string which is to be broken into tokens. Normally, the strtok call is made repeatedly, and for each invocation, a token is returned. When there are no more tokens, null is returned. In the first call, the string is passed, and from second call onwards, null is passed as the first parameter. For example, here we have a quotation from Shakespeare, and we want to break this quotation into tokens based on period delimiter. So we make a call to strtok with string as the first parameter and delimiter, which is a string having a single character period, the second parameter. Then we call strtok repeatedly with null as the parameter. We do this till we get null as a token. And the output is 3 tokens broken down by 2 period delimiters. Now, it is important to note that strtok is not reentrant. It keeps the context of the string internally and keeps on giving the remaining tokens one by one for each subsequent call with null as the first argument. But what if you make a fresh call with another string in between? The context of the earlier string is lost. Suppose we modify the program such that it breaks string into tokens, then each token is broken down into subtokens on the basis of comma delimiter. So the code is modified. After getting a token on the basis of period delimiter 1, we pass that token to strtok, and for delimiter 2, we pass comma. Sure, it breaks the token into subtokens on the basis of delimiter 2, comma, but the remaining higher level tokens on the basis of delimiter 1, that is period, are lost. strtok is not reentrant and we cannot use it in a use case like this, and we cannot use it in multi-threaded applications. So what is the way out? There is a reentrant version of strtok which is strtok underscore r. strtok underscore r has an additional parameter save pointer, which is a pointer to a char pointer. It is an address where a string context of an earlier call to strtok r is saved. For first call to strtok r, where you pass the string, the save pointer is ignored. However, strtok r saves the pointer to the string context here, and next call onwards, you need to pass the previous received value of save pointer. For example, we have two character pointers sptr1 and sptr2. sptr1 is for saving the context of outer token 1, that is delimiter period, and sptr2 is for saving the context of inner token 2, which is for delimiter comma. And it works fine, giving all the higher level and sub-level tokens. Memset provides a quick and efficient way to initialize a chunk of memory bytes with a constant byte c. N bytes of memory pointed by s are initialized to least significant 8 bits of integer c. Mostly memory is initialized to null character or to spaces. That is, memset s\0 m initializes m bytes of memory pointed by s to null character, or memset str space n initializes n bytes of memory pointed by str to space character. Memcpy copies n bytes of memory starting at the location pointed by source src to destination dst. It copies a block of memory from source to destination. There must not be any overlap between source and destination memory areas. memcpy returns a pointer to the destination memory area. And we come to the end of this video. You can find all this information at https://bit.ly/string-library. Please subscribe to SoftPrayog, click on the bell icon and enable notifications. Thanks very much for watching. Take care and stay safe.